Hello everyone. In this video, I'll present the steps required to generate a SimSys expansion pack and enhance it for STM32 CubeMX using STM32 Pack Creator. At the end, you will be able to use STM32 CubeMX to configure your firmware and middleware and generate a project for the IDE of your choice. The agenda is as following. First, I will introduce the STM32 Cube concept. Then I will go through the pack details. Then I will show you the files locations that are going to be used to create this pack. And then we'll create the new pack, add a bundle to the pack, add components, add conditions, associate the components and the conditions, and at the end, enhance the pack for STM32 CubeMX. STM32 Cube is a software ecosystem for STM32 made and supported by ST Microelectronics and proposed to all STM32 developers for free. It combines a set of PC software development tools and a set of embedded software bricks, and STM32 Expansion Pack provides an easy and powerful way to integrate additional components to the project, such as drivers for other ST components, example Sans Serif for instance, or middleware components. The latest STM32 Cube expansions specifications offer the ability to configure and integrate those components directly into the project from STM32 CubeMX and STM32 Cube IDE. The embedded software environment for STM32 offers the standard STM32 Cube MCU packages such as STM32 Cube F4, STM32 Cube H7, or STM32 Cube L5. STM32 expansion packages extend it with additional software components enabling high-level application solutions. Those packages can come from ST Microelectronics to support digital device or high-level software components from ST portfolio. Example, NFC, MEMS, Bluetooth, or even AI, or from ST partners or third parties. Also, it can come from communities and education programs, or from your own personal or professional work to share embedded software components with each other or just within a restricted group. The development process presented in this video follow the STM32 Cube expansions guidelines that are publicly available on www.st.com/stm32cube. There are 3 video tutorials available. The DSP demo pack is using the DSP hardware to generate some internal signals that are then captured and displayed on Cube Monitor tool. The pack is composed of 2 bundles and conditions. The pack is enhanced for STM32 CubeMX to dynamically configure some parameters. It is the package with the lowest complexity. The STDIO pack implements STDIO library functions and redirects them to different channels, such as UART, USB device CDC, or USB host HID. The pack is composed by one bundle which contains multiple components variants that provide alternative solutions. Some conditions are used to link the elements one to another. There are 8 different parameters, some read-only strings and lists. The complexity of this package is medium, and this video is about this package. The third package is called the sequencer package. It is using the sequencer utility for multitasking without an RTOS. The example shows an LED which is switched on and off by 2 threads. There are 2 components which do not have any conditions. There are 6 parameters that use integers, list, and 1 platform setting, and some custom templates. The complexity of this package is high. You will find more information on ST's wiki page and ENCADE SimSys pack page. The application code frequently uses standard I/O library functions such as printf or scanf to perform input and output operations. The I/O library functions can be redirected to use different channels depending on the hardware and the application needs. The most common channels used for STD-in and STD-out are the UART, USB device virtual COM port, for STD-in, it can retrieve data from USB keyboard, for example, in USB host HID class. The SDIU sample pack allows you to easily retarget the I/O library to the channels listed above. The channels can be independently selected for STD-out and STD-in. For example, SCDN can retrieve data from USB keyboard and STDOut can be redirected to the UART. The application code frequently uses standard I/O library functions such as printf or scanf to perform input and output operations. So printf and scanf functions call lower level functions called fputc and fgetc. So these functions are hardware independent. fputc and fgetc calls a lower level functions that are hardware independent. The STDIO is formed of three subcomponents. STDN, which is standard input, is stream for which the program reads its input data. STDOut is standard output, is a stream to which a program writes its output data. And STDError, standard error, is another output stream typically used by programs to output error messages or diagnostic messages. In this pack, STDError will use the same stream as STDOut. In this example, STDOut can use three different channels, which are the UART, USB device full speed, and USB device high speed. STDN can use five different channels, can use UART, USB device full speed, USB device high speed, USB host full speed, and USB device high speed. So why this pack? So not everyone knows how to retarget STDIO. There are different implementations between projects. The use of USB device or USB host is not that simple. And changing an application from using a UART to use USB or vice versa can be difficult and time consuming. And each compiler is slightly different than the other. The goal of this pack is to make it easy for developer to use and retarget STDIO in his application, make it easy for the developer to change from one channel to another, make it easy to use USB device and USB host in the application, save time for the developer, do not worry with which compiler being used, make switching application from one hardware to another as easy as possible, and then use STM32Cubamax to include the proper files in the project, configure the channels being used, and solve any peripherals conflict. The pack will have a dedicated file for each channel. We have 3 channels for STDN and 5 channels for STDOut. The PDSC file will be used to select the proper file depending on the user selection. This will be achieved using a bundle that contains 2 subgroups, STDN and STDOut. STDN will contain 5 variants and STDOut will contain 3 variants. Each pack file requires a handler to the peripheral that should be used for the specific channel. Example, STDN UART and STDOut UART requires the handler for the UART. STM32Cubamax will be used to associate the proper handlers for the proper streams. The PDSC file will be structured as following. One bundle called STDIO with class compiler. Inside the bundle, we have 8 components in the group IO. The channels can be independently selected for STDOut and STDN. For example, STDN can retrieve data from USB keyboard while STDOut redirect to UART. However, there are restrictions. You cannot select USB host full speed for STDN and USB device full speed for STDOut, and USB host high speed for STDN and USB device high speed for STDOut. This is because the USB block cannot be set in host and device at the same time. Each component or variant in the PDSC file will require to connect to retargeting function to the correct peripheral handler. These requirements are going to be configured using STM32Cubamax advanced features. The STDIO sample files require the following handler. So the STDN require the handler name called STDN UART handler and have 4 different possible values. The STM32Cubamax will display these specific parameters with the following conditions. So only the parameter will be displayed only when it is selected in STM32Cubamax. After you download the pack, unzip the pack to C drive under simsys_pack. There, after you extract the STDIO sample, so there will be 2 directories. The first one, the pack directory, where we are going to create the final pack. The source directory contains the files directory. First one is the doc directory that contains the license, this presentation, an Excel file that contains all the details about the bundles and components that we are going to use to create this pack. The source directory contains all the source files that will be used to create this pack. And then there is a firmware directory where we are going to create the projects and include them in the final pack. To open SMT2 Pack Creator, navigate to C, Program Files, STMicroelectronics, STM32 Cube, STM32 CubeMX, and then Utilities. And then you will find Pack Creator, and then double click on STM32 Pack Creator. Before we start with the pack creation, go back to the source code document and open the Excel file. So save the Excel file on the right and the STM32 pack creator on the left, as so. Now we'll continue with the pack creation. First thing on the Excel file, make sure to select the PDSC tab. Now we'll continue with the pack creation. So we'll create a pack from scratch. So the project directory name, we're gonna call it pack. The project folder is our example. The pack name is stdiu_sample. So the vendor can be anything, can be my company name, but for this pack I'm going to use STMicroelectronics. For the pack description is the software component compiler that allows you to retarget I/O functions to a UART USB or USB host keyboard, and then click Create Project. Now we continue with our pack general attribute. So we see here that we have the pack name, the vendor, our description, and now we need to add the license file. So we browse to our files document and select the license, and we select it to be on the root directory. Click apply, and now go to the pack release. So our version is version 1.0.0. Description is initial release, and the date is 2020-07-22, and click apply. Now we'll continue with the pack details and click components, and first thing we are going to add a bundle. So the vendor is STMicroelectronics. So the pack details, so the bundle name is STDIU, so as specified here, and the class is compiler, and we have it in the drop-down list, and the version is 1.0.0, and then add your description. For the document, we go to our file, source, file, document, and select the document and put it in the doc directory, and then select OK, and then select apply, and now click close. Now we are going to create our first component. So we're going to go click add component. So the bundle is STDIO, and the group is IO. Subgroup STDN. Add the description, and the variant is USART. And then click apply. After that, we're gonna add the component file. So click on component, click to add files, navigate to our directory, source, files, src, and then is stdnuart.c, and then put it under the middleware's stdio src. Click OK. Then click Apply. Then click Close. The next component, so we gonna is the USB D CDCFS. We can clone this component from here. So we change the description, and for the variant is USB D CDC underscore FS. Click Apply, and then we go to the files. So we delete all the files and then add file, and we select the USDD and USB-D CDC FS. Click Open, select the directory, click OK, and then click Apply, and then click Close. Next is the USB DCDC high speed for the SDDN. We can clone this component. So for USB high speed, change this HS, click Apply, then we go to the files, delete all files, and then add a file, and select this file for the USB CDC high speed. Click Open, select the source, and click OK, click Apply, and then click Close. So here I can expand this a little bit so we can see the component's name clearly. So next one in the list is the USB host HID full speed. I can start by cloning this device, change the description, and this one is USB host HID full speed. Click Apply, go to Components, delete all, add file, and then select the USB host HID full speed and click Open. Then select the source file directory, click OK, click Apply, and then click Close. Now we'll continue with the latest component in SDDN. So we can clone this component, change the description, change the variant name, click Apply, then go to Files, delete all, add file, and then select the USB host HID high speed for SDDN. Then click Open, select the directory, click OK, click Apply, and then click Close. Now we are going to create the first component on the STD out. We can clone this one for the UART for the STDN. We click this one is STD out, change the description, and here is USART. Click Apply, and then go to Components, delete all files, add file, and then click std out USART and click Open. Then select the source directory, click OK, click Apply, and then click Close. Now the second component in the std out, we can clone the following one. So the subgroup is std out. We change the description, same thing here, USB device CDC full speed, click Apply, and then on the files, delete all, add files, select use std out USB D CDC full speed, select the directory, click OK, click Apply, and then click Close. Now let's finish with the last component. So let's clone the last one that we have created. So let's change the description and change the variant high speed, click Apply, then we go to Component, delete all files, add a file, and then select the stdout USB-D CDC high speed. Click open, select the directory, click OK, click apply, and then click close. So here for these components we have conditions, because someone cannot select USB host full speed and USB device full speed at the same time, and also cannot select USB host high speed and USB device high speed at the same time, because a USB um, block cannot be set as a device and as a host at the same time. So next, we'll see how we are going to create these conditions. So go and select the conditions and then click Add Condition. So the first condition name is going to be stdout USB full speed not selected. So all the details here are available on the Excel file. Add a description for the condition, and then the attribute, the first one is a C bundle. So here go C bundle, and then the C bundle is at stdio, and then the C class compiler, and then the C group IO, and the C sub is std out, and then the C variant is USB CDC FS, and the type is deny. So we are going to deny this condition and then click OK. Next condition, so we can clone the following one, change the description name, update the description details, and then we update this one. So here is, they are very similar. Instead of CDC full speed is CDC high speed. Click update rule and then click OK. Now the third rule. So let's update the rule name, update the description, and then we update the condition. So here the bundle is stdout, compiler, IU. So we change this one to stdn, and is USB HID FS. Click update rule and then click OK. Now let's finish with our last rule. So change the rule name, change the rule description, and then we edit the rule, and here is USB head high speed. Then click OK. Now we are done with creating these conditions. Next, we are going to associate these conditions with the components. So on the Excel file, go back to the PDSC tab. Here we have the conditions, and then we go back to the component. So the first component is SADN USB HID full speed. So this is the component. So we click edit and then add condition, and the condition is stdout USB-D full speed not selected. Click apply, click close. Then this second one is USB SDN USB host HID high speed, so selected, and then the condition is the stdout USB-D high speed not selected. Click apply, close. Then the next one is the USB-D full speed in the in std out, and the condition is stdn USB host full speed not selected. Click apply, click close, and the last one is add the condition with SCDN USB host high speed not selected. Click apply and then click close. So here we'll see that the condition is added in front of the component. Now we are done with the pack creation, so go ahead and save the project. Now we are going to enhance this pack for SMT2 CubaMax. So the files are used in this library depends on peripherals handlers. So for example, the SCDN UART depend on SCDN UART handler for receiving the characters over the UART. The USB device CDC full speed also depends on the USB device full speed handler for receiving the characters over USB in CDC class. The same thing if we are using the USB host, so we need the handler for the USB host that is going to be used to receive these characters from the USB keyboard. The same thing for the SCD out UART, so that depend on a handler, the USB full speed, and the USB high speed in high speed and CDC class. So these handlers we are going to use SMT2 CubaMax to help us configure and set these parameters for our pack. To start, click on the SMT2 CubaMax button to get to this view, and then on the Excel file, click on the CubaMax tab. So here you will see we have all the parameters. So these parameters are the same ones here in these files. So it's very important to keep these names correct during the next part of the video. So now start by click add parameter. We are going to add our first parameter. So the parameter name is the SCDN UART handler. For now, the condition we are going to put always, and later we'll add conditions. So I can add condition right now, but for the purpose of this video, I will leave it later. For the type of the of this parameter is going to be a list, and the values are here. So these are the values. So we click add first value. Result 1 is very important to this value is very important as it's going to be automatically generated by SMT2 CubaMax and used in our software. I will show you how this is working later when we create a project and we create and generate a project using SMT2 CubaMax. Then to add 3 and the display name I'm going to use the same as the name, and the message is, so here put your message and click apply, and now we have our first parameter. So on the tab also here we can create a tab. Let's create a tab here we called stdio, and then click create, and then we'll see the effect of this, and then click apply. So the next parameter, again, so these they come from these files, so is std and USB full speed handler. We're gonna add a parameter, put it here, so we're gonna put always type here is a string read only. We are doing it string as a read only because we have only one possible value. So the display is the same display name, and the help, put your help message, and then the tab is stdio, and then click apply. Next one, I'm gonna add the SCDN USB device high-speed handler. So add the parameter. I'm gonna put here. We are going to use the same display name. Always add the help, and the type is read only, and let's add the default value, and then click no, then add stdio, click apply. So next one is the SDN host full speed. So create a new parameter here, put it here. Always type is read only, and then let's copy the handler, and then we'll add a help message and add stdio, and then click apply. Next, okay, add parameter here. Should you always type is a string read only, copy the handler value, and then copy the description and the help message, and set tab, click apply. Next, add parameter here, always. So this one is going to be a list. Here's the list. The value one, add user 2, to add user 3, add, and then the description, and in the stdio tab, click OK. Next, parameter, always. So this one is a read-only string. Copy the description and stdio out, click apply. Now let's add our last parameter. Always. So this is a read only. That's the value, and that's description, and let's not forget the tab, click apply. Now we are done with the pack parameters creation. So go ahead and save the project. Next, we are going to add the conditions for the parameters. So go ahead and select the first parameter. Here in the condition, we create new condition. So here there is for the std in user selected, and this is for the compiler IUSD and user. So when this condition is selected, and click validate, and then click apply. So for the next parameter, so you can copy the name from here and change it to create a new condition. So stdn USBD full speed selected. So click validate, click apply. Next one is the USB host high speed, USB device high speed. So click here, selected. So stdn USB device high speed, double click, play, apply, then, so next one, you get the idea. So stdn USB host full USB host full speed selected, add condition, validate, select. Now the USB stdn USB host high speed, apply. Now is std out UART selected, std out UART selected, click OK, apply, copy the name, create a new one, std out selected. So std out USB device CDC full speed selected, click apply, OK, and then the last one, did. So this is the add condition. Oops, sorry, cancel. Let's do it again. Right, apply, and now we are done with our parameters. Also here we have a button to preview the CubeMX, so on how these parameters are going to be displayed in CubeMX. In fact, not all of them they are going to be displayed. They are going to be displayed dependent on our selections, and you will see here for the UART you have a drop down list where you can select your handler. The next step is going to be so we are going to generate the pack and import it to STM32 CubeMX and generate our first project. So first thing, file, save, and generate pack. And then click open pack location. So first thing, open STM32 CubeMX. So, and then once CubeMX open, go to install remove, and then drag and drop your pack. Accept the license agreement and click finish. So now we can see that our pack has been added. So go ahead and click close. Today I'll be using the Nucleo F746ZG Nucleo board. So I'm going to create a project. So you can create project by accessing the MCU selector. And the part number, we can type STM32F746ZG. So here is our board. Double click to open the project. So once the project open, so I know in the F746ZG Nucleo board, the UART3 is connected to the ST-Link UART, so we can use it with a terminal. So we go there on connectivity, select UART3, so enable UART3 in asynchronous mode, and then we need to relocate these pins. To relocate a pin, click on the control key on the keyboard and then select the pin, and then you will see the relocation pin possible options change color, so you can drag and drop it while you're pressing on the control pin and selecting the pressing on the control button and drag and drop that pin. So we are good. Verify here that you have the proper baud rate. Now we are going to add our software pack. So go to software pack, select components, and then here we see our pack that we just created. So in STDN select, see here we see the drop down list. Click UART, and then STD out here, see UART, click UART, and then click OK. So now we have a new tab here. It's called Software Packs. So click on SADIO. So here we see our options. So we select UART3 and then we select UART3. So here you see that we see only the SADN UART and SAD out UART handler, and that's because we selected the UART here, and that's thanks to the options that we have created in Pack Creator. So these are thanks to these conditions that we have created in Pack Creator. And also here, see the tab is called STD IO, and that is thanks to this setting in the Pack Creator. And the parameter, so the parameter name here is what is set, this one. So whatever you put here, you will see it displayed here. And this is the description for the parameter. So that is coming from the help message and the display name and the parameter name. Okay, now go to project manager. So the project name is UART. The project location. So we go to the project sample, source, firmware project, and create a directory with the board name. Select that and click open. In the application structure, select basic, and in the toolchain IDE, click generate, select the EW ARM. In the code generation, you can click copy only the necessary library files, and then now click generate code. go ahead and open the project. Now in IIR, go to Application, User, Main. So first, between user code begin include and user code end include, add include stdio.h, and then in the while one loop, let's add our test code. So here our test code will receive a character using getchar, and then we'll use printf to print that character. So now go ahead, build and download your code. So I have my board connected to the laptop. So go ahead and run the project. And now open Teraterm. So go to Setup, Serial Port, and then connect the serial port. And now when you type something, you get it. Okay. So let's go through the project. So here you see in middleware, we have another directory called stdio, and there we have two subdirectories for the compiler IO std and uart, and here we have the compiler std out uart, and here Cubamex, that we see that Cubamex have included the proper files for us. So here you see there is we include a special file. The special file will be your company name dot your pack name underscore conf.h. So you see here the company name is ST Microelectronics. Our pack name is stdiu underscore sample. So the file name is stdiu sample conf.h. So every pack stm. So this file will be generated for every pack. So let's see the content of that pack. So here you see all the handlers that we have specified in the in the pack creator in Cubamex. So with these values, so these values, the parameter name, it's used here. So it's generated as a pound define, then the parameter name. And then the value of that pound define depend on your selection from here. So it's equal to this value. So for example, if we go to the SDN USB full speed handler, we have a default, the value is H USB device FS. And so if we verify here, we have SCD and USB FS handler, and that's the USB device FS. So it's the same values here. So for the URL, since we have a drop-down list, it's different. We'll see what STM32 Cubamex will do. So I will go back here. I will change, for example, for the std in UART as UART2 here, and I will generate the code. Close. Let's go back to IIR. So we see that there has been a change. So we see here that the std in your handler changed from your HUR3 to HUR2. So let's do it again. So here I will change it to so here for the std out UART handler is HUR3, and for the std in UART handler is HUR2. So we go this. So we change this one to 1 and this one to 3, and then generate code. So see that the file has changed. And now you see this has changed from UART2 to UART3, and this one has changed from UART3 to UART1. So I'll go back and change it to the correct configuration with both. It should use UART3, and then click generate code. So how this is working? So since we have selected the UART3, so STM32 CubeMX will create this variable for the HUART3 in main. And what we are doing is simply redefining HUART3 to the std in UART handler and std out UART handler. And the std UART is they're just calling that handler and being used uh, in the transmit and receive functions. Next, we are going to create a project for the USB CDC full speed device. First, close the current IR project. So, and then we go to back to STM32 CubeMX. We go to File, Save Project As, and then change it from UART here to USB device and click Save. So here on the UART, so we don't need it, so we disable the UART, and then we are going to use the USB full speed in device mode. And then in the system core, we go to the RCC, and for the high-speed external, we select crystal bypass. Go to clock configuration, click no. So set 8 MHz for the input frequency, set the PLL input, set this one, and then type 216 and press enter, and this will resolve the clock. Now we have our clock set up. We go back here to the middleware and the USB device. We go and select the virtual COM port class. So here we still have UART selected for the STD-in and STD-out. So to change that, we go to software packs, select components, and then here we select the USB device full speed. And the same thing here, we select USB device full speed. So here, since I selected the USB device CDC full speed, you will see here I won't be able to select USB device host high speed and full speed mode, and that's thanks to the condition that we set on the SimSys pack. So that's thanks to these conditions that we have set up, we have created here, and we have set up for the for our components. So thanks to, if you open the components, so thanks to these condition. So the same thing, so let me select, so for example, if I select here USB host HID high speed, I will not be able to select the USB device high speed. I will be able to select USB device full speed. I can select USB device full speed. So these conditions, they are thanks to this condition on the SimSys pack conditions. So here we have the correct ones, the USB device CDC full speed. Click OK. And here, once we select that, you see these parameters, they have changed to the correct one. So here are grayed out. We cannot change them because these are set as read-only strings. And this is the configuration. So these, because in the CubaMax here, parameters, okay, here in the parameters, here they are set as a string, as a read-only value. Okay. Now we go to the project manager. So the project name is USBD. We are using UART, and we only copy the necessary file. So go ahead and change the stack and heap to 800, and then click generate code. Open project. Okay, here in the application user, we can see that STM32 CubaMax added the files for the USB device CDC interface. Under middleware, we have SCD.io, and there we see that CubaMax added the proper files for the USB CDC full speed for the SCD-in and SCD-out, and also have included the USB library. So here we'll edit the main, so we'll include SCD.io .h, and then we'll put our test code. Okay. Also, we need to do a small change to the CDC interface. So here we need to change this function to a weak function. Okay. Okay. Run the device. Now open DataTerm. So when we go to new connection, we see we have 2 because my board is connected over ST-Link and to the UART on the main controller. So we go and select the second one, click OK, and now when you type there, everything, so it's working properly. Now we are done with the project example. So let's close everything. The next part is we are going to add an example to the pack. Okay, we need to go back to the STM32 pack creator and select Synthesis pack. So we need to create a new release for the pack. So we go to pack releases, current release, and then create new. So the new release is 1.1.0, and for the description, add example project, and for the date is 2020-07-22, and then click apply. Next, we go to the pack details component, and then we click add new bundle. So the new bundle name should be STM32Cube_utilities, and class is device. The version is 1.1.0, and the description is add new add example, and the document we select this document and put it under files document and click OK, then click apply, then click close. You can click on the example tab in the Excel file here. So we are going to add a new component on this bundle. So the bundle is going to be Cube Utilities, the class device, a group application. The description is add, this is example for STD.io, and the variant is example, and the module name is example. And then later we are going to add the condition for this component to work, as this example will require stdin and stdout. So click OK and then click close. Now we are going to add the condition. So we go to conditions and then add condition. So here we have all the detail about the conditions. So the condition name is stdin stdout required. For the detail is re require stdin and stdout. So for the first is the C bundle is stdio. Then add line class C class compiler, add line C group IO, and then C sub is stdout, and then add a require rule. And now we go and change this one from stdout to stdin and then click add require rule. So now we have two rules there. Then click OK. Now we go back to the pack component. We select our example and then we here in the condition and select stdin and stdout required. Click apply and then click close. Now we are done with adding the example component. Now we need to go to the STM32 CubeMX tab. So now we can add two FTL files. So the FTL files they have to have a specific name. They have to their name has to be app underscore your pack name underscore h.ftl and your app underscore your pack name underscore c.ftl. So here it's app underscore stdiu underscore sample underscore h.ftl and app underscore stdiu underscore sample underscore c.ftl. So the content of the C file. So there here we have two functions. So the init function. First one is the init function where we call std underscore init. So this function in fact is present in all the std init stdin files, but in reality is only needed for the USB host HID example. So the USB host full speed and the USB host high speed for SCDN. So it's needed because we need to wait until the keyboard has enumerated and initialized. So for the other example, the function is left empty. So we go to our files, select. So we go to our pack, source, files, src, and then here's our file. And then the second one, here is our file, and that's everything. Now we are done with everything. So the only thing that we need to do is save and generate the pack. Then click open the pack location. So here we can see that we have CubeMX. Cube Programmer has created a new pack with a new revision. Next step is to upload this pack to STM32 CubeMX and then create a new project. So we go back to STM32 CubeMX, we go back to the pinout configuration, and then we go to Software Pack, Manage Software Packs. And there we can install our pack from here. So we can go from local. So that's our pack, and here is our pack, and we click open. Click accept the terms of the license and then click finish. So now click close, go to file, save project as, and then here USB host and click save. So now disable the STD-IO, go to software pack, select components and deselect the STD-in and STD-out and click OK. And now we can see that everything has disappeared. Go file and click save project. So also now go to file and close the project. Click yes to save the project. So now we are gonna go open it again. Go recent projects and USB HA. Now our project is open. We go back to select components. We go to our sample. We go to SCDN. We are going to use USB host HID in full speed mode. And for the SCDN, we are going to use the UART. And also here in the application, we're going to select the example. So here, if I deselect SCD and SCD out, we see here there is showing us that we have an error, and here is showing us the possibilities. We can remove those warnings by selecting the proper components, and go ahead and select OK. So now in software pack and CD out, we have revision number 1.1.0. So we can have the SCDIO here and the SCD, the cube utility example. So for the USB host, we cannot select is fixed because it's a read-only parameter, and for the SCD out is the UART. So here in terms of the connectivity, we go to USB full speed and we enable it in host mode. And also we go to the UART and we enable the UART in asynchronous mode. So we make sure that the UART pin are located in PA9 and PA8. The USB host require an extra GPIO pin to control the charge pump. In the Nucleo board is connected to PG6, so go here, look for PG6. So I click on PG6 and set it as a GPIO output. So now we go to the middleware section and we click on USB host and we select USB HID class. Okay, the host and here USB host, and in the platform settings to control the VBus we go to the GPIO and we select PG6. So now file save project. Now our project is finished. Now we need to go to the project manager, increase the heap and stack. So we have the project name USB host. Everything is set and we copy only necessary library. So click generate code. Okay, now click open project. Now our project is open. So we're going to click on application user. So we can see here that STM32CubeMX has created a new file called app_stdio_sample.c. So this file will be always app_yourpackname.c, and this pack has been created using that FTL file. So if you go open it, so there you will see there are two functions, mx example init and mx example process. And here in the process we have our example, and in the example init we have the call for the init function. And if you open main, you will see that STM32CubeMX has added the call for these two functions, the mx example init and the USB host process file and the mx example process file. The call for the mx example process function. If we go to middleware, stdio, here we can see that we have the USB host full speed for SCDN, and we have the UART for the SCD out, and also here we have the USB host library. Also, we need to do a small change to the USB host platform .c. So we open that and change these two from set to reset, and this one from reset to set. Save the project and download the project. Now run the project. I have a USB keyboard connected to the Nucleo board. So go and open Teraterm, connect to the ST-Link, and now when I type on the USB keyboard, you can see the keys that being pressed. So now stop the project in IIR. Go back to SMT2 Cube IDE, select pinout configuration and select USB host, and here we are going to enable the debug messages. Save the project and then generate code. Click close and then go back to IIR, then rebuild the project. Now run the project and go back to the Teraterm. So clear the buffer, and when you unplug USB cable, you can see the debug information, and also we can see the keys that we are typing. Now the next step is to add these examples that we have created to the SimSys pack. First, start by closing IIR and also close Teraterm and close STM32 CubeMX. Now we go back to our example directory in the source firmware. So there in the drivers, make sure that you have the SimSys driver and the HIL driver for your device, and have the middleware's directory that contains, so in our example ST. So there, make sure that you have any middleware that you are using. So in these example that we have created, we need the USB host library, the USB device library, and also our STDIO library. And then in the projects, so the projects we have to prepare them. I'm going to do this only for the USART example, but this can be should be applied to all the other examples here. So open the project. First, delete all the directories here. Then open the CubeMX project. Now we are going to do a few modifications. See, we're still using the old STDIO library. So go take and check it. Then go to select component. Here set to not selected. Not selected. Click OK and save the project. Now go back again. So get a select component and then select the newest library. Select UART, and select the example. Go to the pack, enable the components and set the proper UART. Now we need to do some modification to the project manager. So go to the project manager. First thing we need to do is we go to code generation and click add necessary library as a reference. Go back to project and then in check use the default firmware location. We go back to our pack, so we click firmware and we select this path, and then we go back to STM32 CubeMX, click browse and we select our path, and now we are done with our preparation. Then click generate code, then click close. Now we go back to our project directory, select the firmware directory, so select that firmware and copy the file path. Now we go back to STM32 pack creator. We click on SimSys pack, then click add additional files, add whole folder, and then paste our folder. Click select, then click on directory firmware. Click OK. Now go file, save, and generate pack. Now this is gonna take some time because we have a big number of files. Click open pack location. Now go back to STM32 CubeMX, close any open project, then go to install remove under STM Electronics, so STDIU sample. Here is our pack, so remove the pack and then open the pack and drag and drop it to install the new pack. Accept the licenses and click finish. Then click close. Now we are done with this pack creation. So in this video we demonstrated how to create a pack from scratch, how to create a bundle, how to create components, how to create conditions for the components, how to create parameters for STM32 CubeMX, how to add conditions for STM32 CubeMX parameters, how to generate the pack, how to generate examples for the pack, and how to add these examples for in the final pack. So if you want to learn more about this technology, so you will find more details on the pack creation in the ST wiki page, where you will find a zip file containing this example package, links to videos containing other example packages demonstration, an auto assessment guide on how you can integrate your software solution, the wiki document explaining step by step how to develop an expansion pack, and a summary of the expected package structure, some Q&A questions that are going to be maintained over time, and links to documents to master the most advanced features of this technology. Thank you for watching this video, and I hope you find it helpful.